lecture we are discussing in the morning Bravais lattices. Bravais lattices. How many types of Bravais lattices are there?
14 types.
14 types. How we have classified them as 14 types? How classified this one? How they are classified as 14 types? Based upon types of unit cells forming that particular crystal lattice. So how many crystal lattices are there?
7.
What are they?
Cubic. Simple
Cubic. Cubic means
simple. All are
A equal to B equal to C, alpha equal to beta equal to gamma equal to
90 degrees.
Next.
Tetragon.
Tetragon.
A equals to B not equal to C.
Alpha equal to beta equal to gamma equal to
90 degrees.
Third.
Orthorhombic.
Orthorhombic.
A equals to B not equal to C.
A not equal to
B not equal to C.
Alpha equal to beta equal to
gamma equal to 90 degrees.
Next, fourth type of lattice.
Monoclinic.
Monoclinic. For monoclinic,
A not equal to B not equal to C. Alpha equal to gamma equal to 90 degrees. Beta not equal to 90 degrees. Trigonal
trigonal
or rhombohedral.
are equal as
Rhombohedral.
Right.
A equals to B equals to C. Alpha equals to beta equals to gamma equal to 90 degrees.
Not equal to hexagonal.
Hexagonal. A equals to B not equals to C.
Not equal to C.
Alpha equals to beta equals to 90. Gamma is equals to 180 degrees.
Next.
Triadic.
Tightening.
A not equals to B not equal to C. Alpha not equals to beta not equals to gamma not equals to 90 degrees.
Right. What is the volume of tightening? Formula for volume of tightening.
ABC
Volume is equal to
ABC under root 1 minus cos square alpha minus cos square beta minus cos square gamma
plus
2 into cos
alpha
alpha cos beta cos gamma.
right? Here we need to understand cos 90 plus theta equal to minus sin theta. Cos 90 plus theta is minus sin theta. And we need to understand few more terms. What are they? Sine of 0 degrees, 30, 45, 60, 90. How to find it?
0
How we calculate that? By using our
half.
So if I consider this as a particular angle, right? So if I assume my palm in this manner, I assume this as 0 degrees, 30 degrees, 45, 60 degrees,
90.
and this is 90 degrees.
90 degrees.
How you found this sine 0 value? number of fingers below this. We have to take root of that number by 2. Sin 30. Root 1 by 2. Sin 45.
Root 2 by 2.
Root 2 by 2. Sin 60.
Root 3 by 2.
Root 3 by 2. Sin 90.
Root 4 by 2.
Root 4 upon 2. Right? Then what will go?
0, 1 by 2, 1 by 2, 1 by 3 by 2.
This is 0,
1 by 2, 1
1 upon root 2,
root 3 by 3 by
3 by 2,
1.
1. Right? So this is sin. Now what about cos? Cos 0, 1, 3 by 2, 1 by root 2, 1 by 2, 0. What about tan?
Sin by cos.
So tan 0,
0.
tan 30, 1 by root 3, sin theta by cos theta. Tan theta means sin theta by cos theta. Right. Next, 1 sin tan 45, 1 tan 60,
2 root 3 by 2.
root 3,
Root 3 by
tan 90, undefined form. So are infinite, right? Right? Now, secant means reverse of cosecant means
cosecant means 1 by sin.
So if you take quadrants, I call this as first quadrant, second, third, fourth. So what we write as all silver tea cups, right? So all means all are positive. Silver means sine value positive and cosecant. Now tell me, cosecant means 1 upon sine or 1 upon cos.
1 by sin.
So here tan and cot. Now tell me, cot means 1 upon tan. Now here cos secant. So secant means 1 by cos. Right? These are the positive terms. This is the reason why we have taken cos 90 plus theta means sin theta, and the value becomes we have taken as minus of sin. Clear? Cos becomes negative and that's why. Now coming to this, by using this formula, what is the volume of it? What is the volume of simple cube by using this formula?
A cube.
Can I cancel? Can I write this one?
Yes.
Already we have discussed in last lecture itself. No? So what is the formula for it? A equal to B equal to C means we write that as volume is equal to A cube 1 minus cos square alpha. What is alpha? 90. Cos 90 0. So cos square 90 0. Again this is also because alpha, beta, gamma all are 90. So 1 minus 0 you will get only 1. So under root write as 1 minus 0 minus 0 minus 0 plus 2 into 0 into 0 into 0. So what you get? 2 into 0. Then what you will do the net value you got? Simply A cube. So volume of cubic cell is cubic crystal is A cube. Now, what is the volume of tetragonal? A square C. Correct? A square C. That's all. Because all are equal and 90. So everything becomes 0. Now volume of orthorhombic. ABC. Volume of monoclinic. ABC under root get that volume. So I don't take care about it. So whatever the value of beta, that value I need to substitute to calculate. Beta may be 60, maybe 45, accordingly the geometry of the monoplane crystal will change. So I am not calculating. Now coming to trigonal, I don't calculate here also. Because I told you that alpha equal to beta equal to gamma, not equal to 90. What is the value of alpha, value of beta, value of gamma? That may be any value, so I don't calculate. Now coming to this hexagonal, here I can calculate. Now what is V? A equal to B means A square C. A square C into root of what you get?
1 minus 0.
1 minus
0.
0 minus 0 minus 90 plus 30 or 120 degrees. So 90 plus 30 means minus sin 30. Minus sin 30. Sin 30 means
1 by 2.
1 by 2. So minus 1 by 2. I need to square it.
Yes, plus 1.
If I take squaring on both sides, what you get? If I take squaring on both sides,
Plus.
you should get that. So squaring on both sides is వస్తుంది మైనస్ కాస్త సింపుల్ గా sin square 30 అవుతుంది కదా. sin 30 ఎంత? sin 30 1 by 2 స్క్వేర్ అంటే 1 by 4. సో ఈ మొత్తం వాల్యూ ఎంత? 1 by 4. If the total value is 1 by 4, what you get? Minus 1 by 4. So what you get here? 1 minus 1 by 4. 1 minus 1 by 4 means
3 by 3.
What you get? 4 minus 1 by 4.
3 by 4.
Right? Root 3 by 4. 4 root means 2. So V equal to, you get it as
A square.
root 3 A square C by 2. Right? Actually, this is the geometry of this structure. So you will get 3 times of this value. Actual hexagonal is 3 times of the value. Now let me explain it again. See this. Just let me show you what is hexagon. Actual hexagonal form is this is hexagon, right? Also this. If I take this as the center, this as the center. Observe here. From this center point, what is this? This is nothing but 1/3 of this total hexagonal cube. Here also you get similar one. And you get 3 such geometries. This is one cube form, cuboid form. This is one cuboid form. This is the second cuboid. This is the third cuboid. So hexagonal is nothing but 3 times of this cuboid form. Okay, so what about parameters of this cuboid? Parameters of this cuboid is two sides will be equal. A, B will be equal. C is not equal. So for this cuboid form, A equal to B not equal to C, alpha equal to beta equal to 90, gamma not equal to 90 means gamma equal to 120. So this is the actual geometry of this cuboid. So what is the actual volume of the cuboid? If I ask you what is volume of this total hexagon, I have to take 3 times of volume of each system. Right? So what I write? Volume of hexagon. Volume of hexagonal crystal is nothing but equal to 3 times of volume of this cuboid. Right? So what is the volume of the cuboid? I have to use this formula. So what is that? A square C, because A and B are equal. A square C into dom 1 minus 0 minus 0 minus 1 by 4, correct? Plus 2 into 0. Now what you get this value as? 4 minus 1 means 3 by 4. Root of 3 by 4. So we write as root 3 by 2. So 3 into root 3 A square C by 4. So sorry, not 4. 2. So this is the actual volume of this hexagon. So what we have calculated by using this formula means volume of only is cuboid geometry. 1/3 power. So what is volume of hexagon? 3 root 3 A square C by 2. So remember carefully about this. In remaining all cases, by using that you got the formula. You got the value. Now here also I will calculate. Reason? Alpha equal not equal to beta not equal to gamma not equal to 90. Not equal to 90 means it may be some other value now. So what is that value? And they have not assigned that value, I am not taking it. Alpha may be 60, beta may be 45, gamma may be 90. Then accordingly I will substitute the values and I will calculate the value. Any doubt in this? So we have calculated volumes. Now let me check about the symmetries. Before going to symmetries, let me check about unit cells. So what are the types of unit cells responsible to construct this cubic? ఎటువంటి యూనిట్ సెల్స్ తోటి నేను సింపుల్ క్యూబ్ జామెట్రీని తయారు చేయాలి. సింపుల్ క్యూబిక్ క్రిస్టల్ జామెట్రీ క్రిస్టల్ అనేది తయారు చేయాలి. హౌ మెనీ టైప్స్ ఆఫ్ యూనిట్ సెల్స్ ఆర్ దేర్? Primitive, non-primitive means body centered cubic, face centered cubic, end centered cubic. How many types of among these four? How many types of unit cells I can use to form this cubic? Except end centered, we can use anything. So, what are the unit cells possible here? Primitive. Can I write that as P? Right? Primitive. So from here on, we use this primitive as P. Right? Then face centered cubic. I write as FCC. Face centered cubic. Body centered cubic. BCC. I cannot use end centered cubic. Reason? End centered cubic means you will have face centers only at top end and bottom end. So when I am arranging the next unit cell, I can change the direction of it. If I change the direction of it, what happens? Instead of top and bottom, I will get that left, right, or front, right. So these both unit cells are not similar. So if the unit cells are not similar, they cannot call them as units. Right? Now coming to tetragonal. For tetragonal, primitive form and body centered cubic. For tetragonal, primitive form and body centered cubic. These are the two possibilities. For orthorhombic, simple, that means primitive, body centered cubic, face centered cubic, and end centered cubic. All are possible for orthorhombic. For orthorhombic, primitive form, body centered cube, face centered cube, and end-centered cube. All are possible. For monoclinic, primitive form and only end-centered cube. For trigonal, only primitive form. For hexagonal also, only primitive form. For triclinic, only primitive. Next, symmetries. Symmetries. For simple cubic, how many types of symmetries are possible? For simple cubic unit cell or for primitive unit cell, how many types of symmetries are possible? How many types of symmetries possible? 23 elements or symmetries are possible for simple cubic. Do you remember?
Yes, sir.
Right? What are they? 13 for simple cubic. 13 axis of symmetry. 13 axis of symmetry. 9 plane of symmetries. 9 plane of symmetries and one center of symmetry. Totally 23 elements of symmetries possible. Here we are discussing only about axis of symmetries and plane of symmetries. Now, if you take tetragonal, for a tetragonal, 5 axis of symmetries possible and 5 plane of symmetries possible. For a tetragonal, 5 axis of symmetries, 5 plane of symmetries. For an orthorhombic, 3 axis of symmetries and 3 plane of symmetries possible. 3 axis of symmetries and 3 plane of symmetries. For monoclinic, 1 plane of symmetry, 1 axis of symmetry. For monoclinic, 1 axis of symmetry and only 1 plane of symmetry possible. Whereas for a trigonal, 7 axis of symmetries and 7 plane of symmetries possible. Whereas for hexagonal also 7 axis of symmetries and 7 plane of symmetries possible. Whereas for triclinic, 0 axis of symmetries and 0 plane of symmetries. No symmetries possible for. So these are the possible symmetry operations for 7 types of crystal lattices. Next, examples of simple cubic, tetragonal, orthorhombic, monoclinic, trigonal, hexagonal, and so on. Right. For simple cubic, example: NaCl, zinc sulfide, diamond,
potassium fluoride, KCl,
potassium chloride,
CaF2,
calcium fluoride. We call it as rutile. CaF2 means rutile.
FeS2,
FeS2 iron pyrites,
Cu,
copper,
Pb,
lead,
Ag, Ca2,
lead, silver, gold, mercury. Right? I don't write mercury form up to this question. These are all examples of simple cubic form. Next, coming to tetragonal. SNO2,
TiO2,
titanium dioxide,
NH4Br,
ammonium bromide,
NiSO4,
nickel sulfate,
CaSO4,
calcium sulfate,
K4Fe,
potassium ferrocyanide, K4FeCl6.
PbW,
Then wolframite. Wolframite. Next, regarding orthorhombic.
KNO3,
BaSO4,
K2SO4,
K2SO4,
MgSO4,
MgSO4,
MgSO4.7H2O.
MgSO4.7H2O. What is this MgSO4.7H2O?
magnesium,
We call this as Epsom salt.
Epsom salt.
It is a luxurious material. What do you mean by luxurious nature?
And
It will wash away everything from your blood. Right?
PbCO3.
Next, lead carbonate,
etc.
etc. Now coming to monoclinic. Examples:
KClO3,
KClO3,
CaSO4.2H2O.
CaSO4.2H2O,
Na2B4O7.10H2O.
borax, Na2B4O7.10H2O. This is nothing but called as borax, crystalline borax.
Na2SO4.10H2O.
Na2SO4.10H2O.
Sir, Na2SO4.10H2O jaiva solvents.
Next,
NaCO3,
sodium bicarbonate,
FeSO4.7H2O.
FeSO4.7H2O,
7H2O.
etc. Next, coming to rhombohedral or trigonal.
NaNO3,
NaNO3,
ICl,
iodine, chloride,
Sp,
antimony,
bismuth,
bismuth,
arsenic,
arsenic,
KMnO4,
KMnO4, etc. Next, hexagonal,
ZnO,
zinc oxide,
CdS, cadmium,
cadmium sulfide,
HCl,
mercury, cinnabar. We call this as cinnabar, mercury sulfide, cinnabar. Next,
AgI,
silver iodide,
magnesium,
magnesium,
zinc,
zinc,
SiC,
silicon carbide.
cadmium,
Silicon carbide is highly abrasive material. That means we cannot scratch the sulfur, right?
cadmium,
Cadmium,
ice,
ice,
graphite,
graphite,
quartz,
quartz,
PbI2,
lead iodide,
etc. Tritium,
tritium,
CuSO4.5H2O,
CuSO4.5H2O, blue color crystals,
C2Cr2O7, potassium,
C2CR2O7,
Ka2Cr2O7, potassium dichromate,
H3PO3,
boric acid, crystals of boric acid. Bas. So these are examples of different types of crystal lattices.